What is a query filter? When you write a query like this, select star from book, you run the risk of getting the whole table handed back to you. Maybe this is no big deal when dealing with an example database like we've been dabbling with here. I mean, after all, what's 5 rows more or less? But what if your book table has 1,000,000 rows, 10 million rows, 1,000,000,000 rows? Hence the need to add a query filter. Select star from book where title equal the Epic of Gilgamesh. That simple where clause filters your query results. It's also possible to combine multiple query filters as well. Select star from book where title equal the Epic of Gilgamesh or title equal Dune. A query filter can be appended to any query and it's often recommended. Check it out. Select book.title, author.name from book, left outer join book author on book.id equal bookauthor.bookfk. Left outer join author on author.id equal bookauthor.authorfk. Where author.name equal Mark Polak or author.name equal Frank Herbert. The gift of writing queries involves joining the right tables, applying the right query filters, and then selecting the relevant columns. That's not complicated, but it does require understanding the semantic relationship between tables. For example, what if you wrote that previous select but didn't make them left outer joins? With such a relatively simple many-to-many relationship between entities, book and author, we've already seen reasons to use both inner joins as well as left outer joins. Imagine writing a report that demands joining 20 different tables. Having learned what Cartesian products are, how joins work, and how to apply query filters, it may feel a bit overwhelming to comprehend how database engines can do all this brute force work. But let's look a little closer and think about finding a single book. Do you know how a database engine looks in the author table and finds books written by Frank Herbert? You may think that the database engine simply scans through the entire author table and looks for every row that matches. But as mentioned earlier in this chapter, what if you had a huge database? What if that database stored 10 million books and 5 million authors? Can you imagine scanning all 5 million rows of the author table every time you needed a single book? As a visual example, my master's thesis is published at the Auburn University Library, a facility that's 5 stories tall. Finding my thesis would entail visiting every book on every shelf of every stack of every floor. How efficient is that? This is why we need indexes.